All right, guys, Mr. Antonucci here, and in this video, we're going to start talking about confidence intervals for a population mean or mean difference. So in this video, I'd like to talk to you about how the learning target I can determine the critical value T star for calculating a confidence interval for a population mean. So when we're doing this, constructing a confidence interval for a population mean, we use what's called the T star critical value rather than a Z star critical value whenever we use the sample standard deviation to estimate the population standard deviation. The critical value is denoted with a T star because it comes from what's called the T distribution. Now, the T distribution is described by a symmetric, single-peaked, bell-shaped density curve centered at zero. And any T distribution is specified by its degrees of freedom and has more area in its tails than the standard normal distribution. So we'll talk about how to do all of this in a little bit. But the T distributions are similar in shape to the standard normal distribution. Like we said, they're single peaked, they're symmetric about zero, and they are bell shaped. However, the T distributions have more variability. That is, there's more area in the tails. So here we have the purple graph is the standard normal curve. The dashed red line is a T distribution with 2 degrees of freedom. Notice the peak is lower and the tails are thicker, so there's more area in the tails than the standard normal distribution. However, something to note is that if you see we have 9 degrees of freedom in this blue dotted line, or curve rather, notice that the peak is higher in the tails, while thicker than the standard normal distribution, are a little bit thinner than the T distribution with 2 degrees of freedom. So the idea is that as the degrees of freedom increases, the T distribution gets closer and closer to looking like a normal distribution. Okay? So, um, so we're more likely to get an extremely large value of T, like bigger than 3, than an extremely large value of Z. So next thing we want to do is talk about how to find T star critical values using table B, and then also how to calculate them on a calculator. So using table D, or excuse me, B in the back of the book, and also you'll get table B on the AP Stats exam formula sheet as well. So you find the correct confidence level at the bottom of the table. So at the bottom of the table, you'll have a confidence level. So this is just a snippet of the full table. It's a full page, but at the bottom, there's different confidence levels. So that's the first thing, find the correct confidence level. And what I have highlighted here is how we're going to find the T-star critical value for a 99% confidence level where the situation has 3 degrees of freedom. So we find the 99% confidence level. Then on the left side of the table, find the correct number of degrees of freedom. So degrees of freedom is n minus 1, where n is your sample size. So we already told you that degrees of freedom are 3, so you don't have to subtract 1 from that. So if you go across from 3, also a note, if the correct degrees of freedom isn't listed, you just use the greatest degrees of freedom available that is less than the correct degrees of freedom. So typically a T table is going to go like 1 through 10 or 1 through 20. Then it's going to skip by multiples of 10, then maybe multiples of 100, and then up to 1,000, and then maybe infinity would be the last line. Okay, so you're not always going to have the exact degrees of freedom on your T table. So you just go to the highest T value that is less than your degrees of freedom. Okay. And then in the body of the table, find the value of T star that corresponds to the confidence level and degrees of freedom. So 3 degrees of freedom is on the table. I go over. 99% confidence level, I go up. And where they overlap is 5.841. So this would be the T star critical value, 5.841. which again, we said it's not, it's more likely to get higher values of a T star critical value than Z. Okay. So due to limitations with the table, technology is often going to be a better option for finding T star critical values. So what I'd like to do is just go over how to calculate those on the graphing calculator with you um, really quick here. So if we have a situation where we want to determine the T star critical value for a sample size of 4 and a 99% confidence interval, here's what you do. You hit second variables to get to the distribution menu, and then you scroll down and pick T interval. Now, I have the TI-83 here. It doesn't have the T interval on it. So, but the TI-84 is going to have that on it. So the steps would be you press second and then variables. So second variables to get the normal, to get the distribution menu. And then you'd scroll down to inv T, which this calculator is in a very earlier version, doesn't have that. So I just have inverse norm. You're not going to want to use that, but you can follow the steps here. Um, so we want a area of 9.99 because it's a 99% confidence interval. And then each tail would have an area of 0.005. So you would do inverse T, put in the area of one of the tails, comma, degrees of freedom, and hit enter, and it's going to give you the the T star critical value for that. Okay. So let's do another example here. What critical value T stars should be used in constructing a confidence interval for the population mean in each of the following settings? So if I want a 95% confidence interval based on a simple random sample of size 12, then my degrees of freedom are going to be 12 minus 1, which is 11. And then if I use table B, okay, I would go over to a 99 or 95 rather percent. Okay. And then on the left, I would look for on the degrees of freedom, I'd look for 11 and I'd see where they overlap. And where they overlap is going to be T star equals 2.201. If you use technology, you're going to have inverse T with an area of 0.025. Because remember, if you have a 95% confidence interval, that means there's 5% split in half over each tail. So you do the area of one tail, 0.0025, and then your degrees of freedom gives you 11. Um, so that's going to give you negative 2.201. So that's going to result in a T star critical value of 2.201. So for part B, if I have a 90% confidence interval for a random sample, 48 observations, my degrees of freedom is 48 minus 1, or 47. So in the table, the degrees of freedom probably are not going to be 47. Okay, you're probably going to have 30, 40, 50, and then you'll have a 90% confidence interval. So you go up from there, and then the one you would pick is 40 degrees of freedom, and then where they overlap, that's going to be your T star critical value. And so for this one, it's 1.678. All right, if you use technology, inverse T, the area, again, since it's a 90% confidence interval, that's the middle 90%. The tails split the 10%, so it's 5% area. So it's going to be 0.05. And then the degrees of freedom are going to be 47. So this would give you a T star or T value of negative 1.678. And then we report the positive symmetrical answer of 1.678. or excuse me, 1.684. So the calculator value is more accurate because it can do specific, precise degrees of freedom, whereas the table may not be able to do that. So now that we know how to calculate T-star critical value, an important point needs to be made, and that is that inference for proportion uses Z and inference for means is going to use T. And that's why it's one reason it's important to distinguish categorical data and or distinguish it from quantitative data. All right, guys. Well, that's it for this one. Make sure you continue on to the next one.